In this video lecture, I'll be explaining to you the merge sort algorithm. We'll see what is merge sort, how it works, and we'll also learn the entire algorithm with the help of an example. With that said, hey guys, I'm Amir Salam, and on this particular channel, I upload content related to coding, technology, and self-development. If this is something within your interest, then consider subscribing to my channel. Now, without wasting any more time, let's jump right into the topic. First of all, what is merge sort algorithm? Well, straightforward, it is a comparison based sorting algorithm which follows a divide and conquer technique. Merge sort recursively divides a given array into smaller sub-arrays until it reaches to a point where further division is not possible. That is known as the base case. Once it reaches base case, then what we do is we try to sort the elements and then we'll merge them together until we obtain a fully ordered or fully sorted final list of elements. So basically what merge sort does is when you provide an array or list of elements, it starts to divide this array into smaller and smaller and smaller sub-arrays until it reaches to a point where further division is not possible. Once it reaches this case, what happens is it checks each array or each element individually, sorts them and merges them back. Then again it moves upwards, looks into the array, compares, merges, sorts and moves forward. Now this is how merge sort functions. Now this might sound a little tricky for you or a little confusing initially, but trust me, this is a very interesting algorithm, sorting algorithm, and you'll absolutely love the way it works. Now if in order to understand the merge sort algorithm, you should have a understanding of at least a basic understanding of what is recursion. So if you don't know what is recursion, then I'll drop a link down in the description box where you can go and watch one of my videos where I have explained recursion or recursive function in under 8 minutes. So now how merge sort works is I have explained it to you. It starts to divide this array into smaller sub-arrays, and once it reaches the base case, it compares the elements, sorts them and merges the array until we obtain a fully ordered or a sorted array. So this is basically how merge sort works. Now let us look into the algorithm of merge sort. Well, in merge sort we'll be using two functions, and first function what we'll be doing is we'll be passing the arguments the array itself, and we'll be passing the leftmost index and the rightmost index. Now what happens here is we'll check if L is greater than R. If L is not greater than R, or is L is equal to R, that means the array is not dividable, and we'll skip the entire function itself. If this condition is true, then what we'll do is we'll calculate the middle point. Now why do we need the midpoint? Is because we have to divide the array exactly at its center. So we'll be calculating the midpoint or the middle index number. Once we get that, we'll be recursively calling the merge sort algorithm again and again until we reach the base case. So as you can see, with this particular recursive calling the function, once again we'll be sorting, we'll be dividing the leftmost part of the array. For example, if this is my array, okay, it will be divided into the leftmost, this will be the leftmost, and this is going to be the rightmost array. So first we'll be dividing the leftmost array, then the rightmost array, and then we'll call the merge function which will sort the array and merges them back into one single array. So in merge function what happens is, again it takes arguments, that is the array, the leftmost index, the middle index and the rightmost or the last element index. Now what happens here is we'll first calculate the size of the left array and the right array, because we have to create a temporary variable which will be storing this array, right, the left array and the right array. So we'll be calculating the size of left array and the right array, and we'll be creating an array, a temporary array, to store all the elements. Once we're done with this, we'll start to insert the elements into the left and right array. Okay, then we'll compare the elements. Once the comparison is done, we'll place the elements in the right position, and the leftover elements have to be placed in the right position. So this is basically how the algorithm works. Now as you can see, here is the code. In this particular code, as I said, we'll be checking the condition. If the leftmost index is lesser than rightmost index, then we'll get into the code block. Then we'll be calculating the midpoint. Then we'll be calling the function recursively. First one to divide the leftmost array. Then then we'll be calling the rightmost array. If the function recursively calling the function to divide the rightmost array. And once we are done with that, we'll be calling the merge function in order to sort and merge the elements. Now, as you can see, I've explained this part. That is, we need to calculate the size of the left and right array. We'll be creating two arrays, that is left and right, of size n1 and n2. Then we'll have to use two for loops to enter the elements into the left and right array. Then once we're done with this, now here is the main part of the algorithm itself. Now what happens here is, as you can see, there are three variables. Now I variable is for left array, j variable will be used for right array, and k variable will be used to sort the original array. Okay, will be used to enter elements into the original or the final array. Now what happens is, while I is lesser than the value which is in n1 and j is lesser than n2, will proceed with the with the while statement or the while loop. Now here there's a condition statement. If the left element in the leftmost array is lesser than the element in the rightmost array, we have to enter the leftmost array element into the final list. So this might sound a little tricky to you. So instead of explaining this code to you, I'll explain how merge sort works. Now suppose I'll take an array of size maybe 8. I'll enter elements, okay, suppose 3, 7, 1, 0, then 5, then 2 and 4. So how many elements? 1, 2, 3, 4, 5, 6, 7. I need another one element. I'll take it 8. Now the index number is gonna be 0, 1, 2, 3, 4, 5, 6, 7. Now first part is, first we have to divide the array until we reach the base case. Okay, what happens is, this array will be divided into an equal half. So this will be divided into left part and right part. Now this array will be again split into another sub arrays. Now this array has been split into this, and here this. Now this will be again split into half. So what we'll be obtaining is, we'll obtain a sub array of 3 of 7, 1 and 0, 5 and 2, 4 and 8. Now we still haven't reached the base case, so we'll again be splitting these elements. So what we'll obtain is 3, 7, 1, 0, 5, 2, 4 and 8. Now this is our base case. Now why is this our base case? Because further division of this this array is not possible, because each element here is an array itself, and you cannot divide an array which contains only one element. So what happens here is, we will now start to merge these elements. How merging happens is, remember we have I variable for leftmost array, and j for the right, and k to be the index number of the original array. Okay, here I'll have the original array. Okay, this is not possible because of my camera. What I'll do is, I'll write it down over here. Suppose this to be our final array. Okay, and I'll write down the index 0, 1, 2, 3, 4, 5, 6 and 7. Now what happens is, first I'll be comparing these two elements. Okay, they're in right position, so I'll be merging them into one array. That will be getting 3 and 7. Next I'll be comparing 1 with 0. So I'll have to place 1 here and 0 there in order to arrange the array in ascending order. Again I'll be comparing 5 with 2. I have to place 2 here and 5 over here in order to obtain a proper ascending order. Again 4 and 8 are in proper order. Now what happens is, now I have to arrange or merge these two arrays. So I'll check, this is ith variable and this is jth variable. I'll check if the element at ith position is lesser than element at jth position. We see that the element at jth position is lesser than the element at ith position. So what I'll do is, I'll place 0 first, and the jth position will be incremented to 1. Now I'll check if element at ith position is lesser than element at jth position. The condition is that the element at ith position is greater than element at j position. So what I'll do is I'll be placing 1 here. Once I'm done with this, I'm left with only this array, and this array will be copied as it is. So as you can see, this subarray is sorted. Now next we have to sort this array. Now this is ith position and this is jth position. What I'll do is I'll compare if the element at ith position is lesser than the element at jth position. The condition is true, so I'll place 2. I'll increment I to 1. Now I'll compare if element at ith position is lesser than element at jth position. The condition is false, so I'll be incrementing, I'll be adding the value 4 into this place, and I'll be incrementing jth position by 1. Now I'll compare, is element at ith position lesser than the element at jth position? The condition is true, I'll place 5. Now the only element remaining is 8, so I'll place it over here. Now remember, I have to combine these two arrays to form one final array. Now what happens is, now we have seen how variable I is used, j is used. Now we'll also use the variable k. What happens is, now first k will be pointing here, okay. Now I will be pointing here and j will be pointing to this particular element. First we'll check, is element at ith position lesser than element at jth position? The condition is true. We'll place the element at ith position at k is equals to 0. Now what happens is, I will be incremented and k will also be incremented. Now we'll check if element at ith position is lesser than element at jth position. The condition is true. We'll write it down over here. K value will be incremented, I value will also be incremented. Now we'll check if element at ith position is lesser than element of jth position. The condition is false. Element at jth position is lesser than element at ith position, so we'll be placing 2 over here and we'll be incrementing the pointer j. Now we'll check if the element at ith position is lesser than element at jth position. The condition is true. We'll be writing 3 here. We'll be incrementing k. We'll be incrementing ith position to 7. Okay. Now we'll check if element at ith position is lesser than element at jth position. The condition is false, so we'll write down 4. I'll increment j over here. Now I'll check if element at ith position is lesser than element at jth position. The condition is false, so I'll write down 5 here. J will be incremented, also k will also be incremented. Now I'll check if element at ith position is lesser than element at jth position. The condition is true. I'll write down 7. K will be incremented. We are done with this entire sub array. Now the only element remaining here is 8, which will also be inserted to this place. Now hence we have obtained a fully sorted array, that is this particular array, and we have obtained this using merge sort algorithm. I hope you have got a good understanding of what is merge sort algorithm. To summarize things, merge sort algorithm takes input as an of the entire array. It continues dividing this array into sub array recursively until it reaches the base case. Base case is nothing but where the array cannot be further divided into sub array. Once it reaches base case, it compares each element individually, sorts them into smaller arrays, then again compares arrays with each other and it keeps on merging them until it reaches to a point where we get or obtain a fully sorted or fully properly ordered array. So that was it for this particular video. I hope you liked it. If so, then hit the like button, and if this channel is worth subscribing for you, then consider subscribing. We'll see you in another one. Till then, bye bye.